Hi guys, my name's Mr. Lead, and today I'm going to be talking about how our solar system was discovered. Now, when we talk about this, a good reason to talk about this topic is we get to understand how scientific discoveries get made. We understand how they're made using deductive reasoning, and we understand how they're made using technological advancements. And another good reason to talk about this topic is we get to learn about the scale and wonder of our solar system, which is so grand. So to kick things off, we're going to start by looking at the first discoveries, the first ideas about our solar system. So back in ancient times, the first astronomers looked at the sky. They saw all the brilliant dots that filled the sky. They worked out some of these dots stayed in the same place. Hence, these dots would be stars. And they worked out that some of these stars, because they stayed in the same place, you can map them out and group them together in constellations. And so depending on where you are on Earth, you can use constellations to know where you are, and you can use them for direction. That's why the Southern Cross is only on the Southern Hemisphere, and that's because it's only on the Southern Hemisphere, that's why it's on our flag in Australia. But of course, these first astronomers also found that some of these dots in the sky move. So what do you do with that sort of information? Well, they used what's called deductive reasoning. Now, deductive reasoning is where you take two pieces of information and you form a conclusion based off that information. So the information these astronomers had was that stars are shiny dots that don't move, but there are some shiny dots that are moving, therefore those shiny dots aren't stars. Yeah, right, they weren't stars, they were planets. So if you look in the sky, you can actually see some planets with your naked eye without a telescope or anything. And this is what you can see in our solar system with your naked eye. And this is for hundreds of years, almost thousands of years. This is what we knew as our solar system to be, just from Sun to Saturn. That was it. But the big question was, how is our solar system structured? And this was a debate that went on for hundreds of years. Is our solar system structured with the Earth in the center, or with the sun in the center? Now, we look at this and we laugh because, of course, the Earth isn't in the center of the solar system. But if you look at the pieces of information that people had back then it makes sense that they thought that the Earth was in the center. So here was the deductive reasoning that people like Aristotle and other philosophers back in ancient times made. They had two pieces of information like, these planets and stars move through the night sky, and we on Earth don't seem to move. And so therefore, their conclusion was, the Earth is in the center. And this was the geocentric model, the Earth in the center model. And again, we laugh at this. This is not how it's actually set up. But based on the information they had, it was sound deductive reasoning. So there were actually some people who proposed that the sun was in the center, but because there wasn't enough proof at the time to support this, then this theory of the sun being in the center, the heliocentric model, was rejected. So it wasn't until other pieces of evidence came up that we could start making new conclusions, forming new deductions. So this was one piece of evidence that baffled astronomers for ages. Retrograde motion. When you look at the planets in the sky, and if you watch very carefully at the way they move through the sky, it sort of looks like they loop around. It looks as if they're reversing direction. So one astronomer named Ptolemy thought that if we see retrograde motion and we know that the Earth is in the center, then that means that all these little planets are spinning around as they move around. And so this was what people thought retrograde motion meant for ages. Until over 1,000 years later, this guy named Copernicus came along and said, well, I'm going to make a new deduction here. I'm taking this old piece of information where you can see retrograde motion, but I'm going to add a few mathematical factors to it, a new piece of information. Therefore, I'm forming a new conclusion that the sun is in the center. And we're seeing, and this is the heliocentric model, and we're seeing retrograde motion because if all the planets move at different rates, and we on Earth are moving as well, then of course it will look like our planets are spinning around because we're moving and turning at a different rate to what they are. But the problem was the Catholic Church at the time, which had all the power, saw this and thought that this was heresy. The reason they thought this was heresy is because they supported the geocentric model, because they thought Earth was so special and was so divinely created by God that everything else had to revolve around it. Because of this theological argument, everyone still conformed to the idea that the Earth was in the center. We needed new information to challenge this idea and to form a new conclusion. And that new information came with technological advancements. Galileo was the first person to use a telescope for astronomy. He wasn't the first guy to invent it, but he was the first one to use it for astronomy. And by using a telescope, he discovered many things, such as the fact that the moon has craters, and that Saturn has rings, and that other planets have moons. This is basic information for us now, but this was mind-blowing back in 1610 AD. What he also discovered was that Venus has phases Venus has phases, just like our moon. But the phases of Venus didn't make much sense unless you saw the phases of Venus to be due to the sun being in the center of the solar system. So with this piece of information, and alongside some other pieces of information, such as Copernicus's theories, and also someone named Kepler came up with a whole other theory about planetary motion being in an oval. All this evidence started stacking up against the geocentric model. But the Catholic Church still tried to fight back. They still tried to support the geocentric model, so much so that books that were written by Copernicus were banned, and they even put Galileo under house arrest for what he believed. It wasn't until Isaac Newton came along and proposed his ideas of gravity that we finally saw the claims against the geocentric model to subside, and we finally saw support for the heliocentric model. This whole ordeal just goes to show that science doesn't disprove the Bible. I mean, the Bible never actually said in the first place that the Earth is in the center of the universe. But all those scientists that were coming up with ideas that disproved what the Catholic Church was saying, all those scientists were actually still Christian. You can read this quote by Galileo here. It's a great one. So this was where our solar system was at, and by those technological advancements, we were able to discover other planets such as Uranus, Neptune, and Pluto. Now, speaking of discovering Pluto, this was actually the image they used to discover Pluto. Can you find Pluto in this image? Well, I suppose you probably couldn't because everything just looks like stars. But we got to remember, how do we work out the difference between stars and planets? That's right, planets move. So to discover Pluto, we actually need to take 2 photos. And so that's what they did. They took 2 photos and they saw that one of these dots here on these 2 photos actually moved from one place to the other. We saw this dot move from this place to here, like move from here to here. And because that one dot moved, we were able to then discover that dot was in fact Pluto. Now, I know what you're probably thinking. Pluto's not a planet anymore, Mr. Lead. And yes, you're right. And there's a reason. In the 1990s, a very, very powerful telescope called the Hubble telescope was released and launched into space. And that telescope helped discover what's known as the Kuiper Belt. The Kuiper Belt was a massive collection of space objects that reside past Neptune and around about where Pluto is. And with each of these discoveries of these space objects, a lot of these space objects were about the same size of Pluto. And so that kind of begged the question, hang on, do we call some of these planets? It wasn't until in 2005, a space object that was just a little bit, or at the time it was thought to just be a little bit bigger than Pluto, was discovered. This was Eris. Eris was thought to be a new planet. And so the scientific community were like, hooray, we found a 10th planet. But then the IAU, or the International Astronomical Union, saw this and they thought, hang on a minute. If we are just going to say Eris is a planet, then we got to call all of these random things that we just found for the past 15 years planets as well. We got to call everything here in the Kuiper Belt planet. So where do you draw the line with labeling things as planets or not? So the IAU decided we've got to create a definition of what a planet is. A planet needs to orbit the sun, it needs to be spherical, and it needs to be able to clear its neighborhood so it's not surrounded by all these random neighbors. So Pluto does orbit the sun, it is spherical, but because it lives in the Kuiper Belt out here, and because it's surrounded by all this other random stuff, it doesn't count as a planet. So the IAU defined Pluto, along with these other guys, as dwarf planets. And this upset so many people. There were actually protests to try and get Pluto renamed as a planet. And they actually had a little bit of reason, good reasoning too. Because some scientists looked at this definition of what a planet is, and they said, well, the third thing here, your third definition here says a planet needs to clear its neighborhood. It needs to move any space dust and asteroids and all of those things. It needs to be able to, using its gravity, just move them out of its way. But Earth is a planet, and Earth doesn't clear its neighborhood. Therefore, deductive reasoning here, clearing its neighborhood doesn't make much sense, and therefore Pluto should be a planet. The IAU there said in response to this, so do you want to just name all of these random things planets as well? Because if we're just going to say that our definition is wrong, we've technically got to say, sure, Pluto's a planet, but so are 100 other things. Our solar system would have hundreds of different planets. And if we're going to call all of these planets, isn't that just a bit excessive? And so in response to this, the scientists said, yeah, sure, that is a bit excessive. So that's the stalemate that this debate is at the moment. Pluto is not a planet, it's a dwarf planet, but it's really odd in the way it's named a dwarf planet. So what's left to discover from here? Well, we can explore. There is so much we can learn. There's only so much we can learn using telescopes on Earth. That's why we sent a man to the moon, and that's why we send rovers to other planets, and that's why we send probes to go far out. But there's also still things we can learn from our telescopes as technology just keeps on improving. In 2016, it was actually discovered that there may be a ninth planet out there that's not Pluto, a planet about the size of Neptune that we've never discovered because it's pitch black and blends in with space. That planet may exist out there. And as technologies keep on improving, we get to keep discovering all these amazing things. And I think all of these discoveries help highlight the amazing universe that is out there, that is just so immensely, it's immensely awesome and so intricately designed. Thanks for watching.